Okay, we're going to look at investigation 2.3, which is just loaded with a lot of stuff. And I'm going to hit all the high points, so there are questions that will have answered, and that I might not directly answer, but all of the work that you need is going to be here. Okay, so in A, they say 10 oranges are $2. They're looking for the unit rate. There's two ways to get a unit rate. I can do oranges per dollar, or I could do money per orange. So in the first one, I'm saying how many oranges can I get for $1? Well, if I can get 10 oranges for $2, I can divide by 2, and that would mean 5. And that is, and then they over here you're going to be filling out a table, but this is the piece where you're going to get from that first thing that they ask you to do. 5 oranges are $1. In the second unit rate, I want to find out, well, okay, but how much? I just want 1 orange. So how much does 1 orange cost? And in that case, I'm going from 10 to 1, so I'm going to divide by 10. And the price for orange is going to be 20 cents. And I can add that to my table right here. Okay, and if I have 20 oranges, this is what's great about a unit rate. If I have 20 oranges, then I know how to get the cost of all of them. I'm going to take the 20 and I'm going to multiply it by 20 cents, and I'm going to get $4. That's kind of a lousy $4, but whatever. For 11 oranges, I can even find 11 oranges times 20 cents is going to be $2.20. Okay. Now, if I want to start with 260, okay, 260, I know that each orange is 20 cents. So if I spent 260 divided by that 20 cents gives me 13 oranges. So the unit rate really helps you figure out how much you can get per something, how many oranges I can get per dollar, or how much 1 orange would cost. So oranges per $1, or money per 1 orange. And if I was going to write this as an equation, in the book it mentions that if you have the number of oranges is 5 times the cost. So if this is 20 cents, 20 cents times 5 is that dollar. You see, that matches that right there. The other way would be to do, if I want to find the cost, I could just multiply that 20 cents times the number of oranges. So notice that the unit rate is the number I'm multiplying by in the equation. And that's going to be very, very important. Okay, so you need to make sure that you understand that. When you're multiplying to find a more than 1, you're taking whatever that unit rate is and you're multiplying it by that number. Okay, so let's go to B. B says I have 20 gallons and that will take me 600 miles. And again, they want you to do the unit rate both ways. So I'm going to have gallons per mile and miles per gallon. Oh, okay, I made a mistake here. Let me just get that. This would be gallons, and this would be miles. Oh, that is ugly, ugly, ugly. Okay, let me get that fixed up. Yeah, there we go. Okay, and so this is going to be miles, and this is going to be gallons. Okay, so this is like real time, right? You're seeing all my mess ups. Okay, so I'm looking at the miles, the gallons per mile and miles per gallon, and I'm saying if I go from 600 miles to 1, right, I'm going to have to divide by 600, which means I'm going to divide the top by 600. Okay, and so I'm going to get, if I put that in my calculator, I'm going to get 0.03 gallons for every mile. Doesn't seem like very much, right? 300th of a gallon for a mile. I could get somewhere. Okay, and in the other one, I'm going from gallons, 20 gallons to 1 gallon. So I'm dividing by 20. Let me make sure I put over here that we divided by 600. Okay, and so I have 20. I have 20 divided by 20 is 1, and 600 divided by 20 is 30. So that's 30 miles per gallon. In this one, they're not looking for a rate table. They're looking for you to graph, which I think is awesome because you can see unit rate in an equation, you can see unit rate in a table, and you can see unit rate in a graph. So let's do this. For one gallon, it's going to be 30, okay? And so that's going to be 1 gallon is 30 miles. 2 gallons is going to be 60 miles. So I have 2 and 60. And remember, the X goes first and then the Y. 3 miles would be 90. So that's going to be 3 gallons and 90 miles. And I do want you to notice that I am going in a straight line. Notice this, which means I'm going up by the same amount every time. And if I have a unit rate, I absolutely are going up by the same amount every time. An important point, which they don't ask about, but I think is really important, is that 0, 0. And we're going to talk about that 0, 0 as we talk more about constant proportionality. But the fact that it goes through 0, 0 is significant. So I want you to remember that. Okay, I'm looking over at the side. They were talking towards the end of this problem. They talk about two of the students are arguing. One says I'm going to use the unit rate, and the other one says, you know what? I can put it I can do 600 miles to 20 gallons, and I can just put it to 4. So let's see if they get the same answer. Okay, so if I take 20 and I'm going to 4, I know I'm dividing by 5. And if I take that 600, right? Because if I divided the bottom by 5, I have to divide the top by 5. I'm going to get 120 miles. Okay, so let's see if the one down, if Lisa is right. If I take this and I multiply this by 4, then I'm going to multiply 30 by 4, and I would still get 120 miles. So either way works. I can scale it up using the unit rate, or I can scale it up using the original rate I started with. Either way, it works. Okay, the last problem, C, they're talking about where you're going to buy your pasta. And I love pasta. I don't know if you guys love pasta, but I could eat pasta every day. Love it, love it, love it. Okay, so they have 2 stores. One is More for Your Money, and the other is Fresh Foods. And I've given you the answers. The answers are here. I'm not going to work it out, but I want you to go back and look at your answers and make sure that you're getting that Fresh Foods is definitely the winner. Okay, Fresh Foods, I can get 1.2 boxes for $1. And at More for Your Money, okay, I can only get 1.17 boxes for $1. So go back and check your work. I mean, it's a kind of a fun problem, and it's certainly something we do when we go shopping every day. We're always looking for the best buy. Okay, good job.